All right. Um, Section 5, file sharing. So in a multi-user system, so files need to be shared among users. Okay. But two issues arise when file sharing is allowed. So first is access right, and second is to manage the simultaneous access of files. Okay, first about access rights. So here are the types of access rights that can be assigned to a particular user to a particular file. First is none, no right at all. Second is knowledge, meaning the user knows that that file exists. Third is execution. The user can execute the program file, okay? Can load but cannot copy it. Fourth is reading. The user can read the file and can copy it and can execute it but cannot modify it. Fourth is appending. The user can add data to the file but only add, cannot modify or delete. Fifth is updating. The user can modify, delete, and add data to the file. And then the seventh access right is to can change the protection. The user can change the access right granted to other users. And finally, deletion. The user can delete the file from the file system. Okay. So the category of users will be the owner of the file, and then a specific user, individual users designated by its ID, and then user groups, set of users, not individually defined, but they are only the groups, and finally all users, okay, all users who have access to the system, and these are for public files. Okay, so next section, record blocking. Okay, so records are the logical unit of access of a structured file, whereas block are the unit of input-output with secondary storage. For input-output to be performed, records must be organized as blocks. So blocks are the unit of input-output with the secondary storage. So given the size of a block, there are three methods of blocking that can be used. First is fixed length blocking. Second is variable length blocking, but can be spanned. Third is variable length blocking, but cannot be spanned. Okay, so the issue with fixed length blocking is there will be internal fragmentation. There are unused space at the end of each block for records, but not for bytes. Okay, but it's appropriate to be used with byte stream files. Okay, so this is fixed blocking. So we see that each record or each file, each record has the same size. Okay, same size of block. Okay, and when they are put in the tracks, okay, in the secondary storage, see for example here shows that there are two tracks. Okay, so data are put in similar size, same size records. So these two tracks can fit 8 records. Okay, and they are waste of space due to the block size constraint when fixed record size are used. Okay, and then if variable blocking variable size blocking are used, okay, we can make the most efficiency in the space usage if span variable blocking span is used, because uh, first we can store the records in different sizes. Next, when there is a physical gap due to the hardware design of the track, okay, we can span the record to break across the different physical area. Like here, for example, record 4, the size of record 4 is larger than the size of this area, so part of record 4 is put here, and the remaining are put in the next, okay, segment, next area in the track. Okay, also a record can also span multiple track. For example, this record 6 here, part of it is in track 1, and some other part is in track 2. Okay, so this makes efficient use of storage, but actually it's hard to implement. So the third type of variable blocking, the third type of blocking is variable with unspan. Okay, so records are kept in variable sizes, but they cannot be spanned across multiple sides of the track or multiple tracks. Okay, so it has some waste of spaces. Okay, so for detail on how to arrange this, there's another video showing it. Okay, you can watch the video.
This is an example of variable blocking, span versus unspan. I'm going to show how span and unspan are different. Okay, so we are going to have 2 tracks, and each track, for each track the size is 1 megabyte, which is equivalent to 1024 kilobytes.